In this video, I'll be talking about the BMH algorithm for string matching. So firstly, what is string matching? To put it simply, string matching is finding a string within a larger string. This is often used when you're searching through web pages for a specific word. For example, when you're at a page and you're looking for the word cow, you Control F, you type in cow, and it would find the word cow as well as all the occurrences possibly. So let's get started. First of all, we're gonna need to make an alphabet table, and this alphabet table will be used in order to skip the certain number of letters in the string, which we shall show later on. So firstly, we're gonna use the word penguin as our example, and we're gonna start from the letter A and move our way through the alphabet and basically update the positions of each letter. As you can see, I've put down 7 in all the alphabet letters, and that is because that will be at the end of penguin, and so that means that that letter does not exist in the word penguin. So we'll start. In the letter A does not exist in penguin, and so we skip that and move on to B, and B does not exist in penguin either, and so we skip that and move on to C, and so on until we hit a letter that does exist in penguin, which would be E. And if we're counting from the left and counting from 0, E would update it to be 1. And so we move on to F. F does not exist in penguin, but G does exist in penguin, and so we update the position to 3. And we continue this until we have gone through all the alphabet letters. Now, as you can see here, for N, there's 2 N's in the word penguin, so generally we go for the N which is at the rightmost. However, in this case, because we are not going to take note of the last letter because we don't really need it for the shifting of the letters, so we're going to take the first N, and that will be position 2. And we are done forming our alphabet table, and we shall move on to the next step. In here, first of all, I'm going to get a string that we're going to find the word penguin from, and this string would be a bunch of penguins, as you can see along the top of the slide. First of all, we need to align our word penguin against the string and compare the last letters. In this case, we are comparing H and N. However, H is obviously not N, and not only that, but H is not in the word penguins, and so we can safely assume that that whole front area will not be the start of penguin at all, and so we can skip all of that and shift our word penguin up so that the letter P is at position 7, and we compare the last letter again. In this case, the letter is N, and it does match, and so we can move on to the previous letter. This would be E, and E is obviously not I. However, E does exist in the word penguin, and so we shift our word penguin up so that it's aligned, which is easily done using the alphabet table. Now we compare the last letters, and if they match, we keep moving on to the previous letter until we find a place where it does not match or where we've matched the first letter. As you can see here, we have matched the word penguin. However, I'm going to continue this video until we have matched the whole string, just in case there are any other more occurrences of the word penguin. To do this, we only need to shift up our word penguin by 1 position, as we are not sure if there are any repeats or not. And so we compare the last letter, which is S and N, and S is not N, and S does not exist in the word penguin, and so we are done matching this string. So we've only found 1 occurrence of penguin in the string. And now for the computational complexity of this algorithm. Assuming that N is the number of characters in the string to search through, in our case it would be a bunch of penguins and the number of characters in that. And m is the number of characters in the string to search for. That is the number of characters in the word penguin in our example. The worst case would be big O and m comparisons. An example of when this would happen is, for example, if you had a large string of letter A's and you were searching for a small string consisting of only A's as well. And so you would check every letter right from the start and you would find a match. And so you would shift one position only because you're not sure if there's any repeats or not, and you check all the way from the back to the front again, every single character, until you find a match, and you keep shifting on one place. And so essentially each character in the string that we're searching through would be searched through m times, and so that is why it is n times n number of comparisons. And in the best case scenario, it would be big O n over m comparisons. And the reason for this would be if you keep skipping the word that you're searching for throughout the whole text, and therefore for the n number of characters you keep skipping m number of times, and therefore you would have n over m number of comparisons. And thank you for listening to this video, and I hope that it's helped you understand the BMH algorithm a bit more. And yeah, thank you.